Hello, I'm John Barham, developer of the Doubletalk sequence. I'll show you what the sequence does and how to interpret the results so you can understand what your device is doing when Doubletalk occurs. The audio is in 2 channels, so I suggest you listen with a stereo headset or something like that because it will help you understand better what's going on while the sequence runs. First, let's just say what Doubletalk is. It occurs when 2 people are having a conversation, and either accidentally or on purpose, one person tries to talk while the other is still talking. Now, that can happen accidentally, or it can happen on purpose if somebody needs to interrupt. But a device needs to be able to handle that without clipping off the other person's speech or making other nasty sounds. And so that's what the test is intended to reveal. I'll show you how that is intended to be measured with a following slide. The sequence implements 2 Doubletalk standards. First one is from ITU P502. It basically is a method that was originally made for an artificial speech, but it's been adapted for use with real speech. The result is 1 parameter for the entire test. It's something called the attenuation range, which is obtained by statistical methods. The attenuation range is basically how much loss there is when signals are going both ways at the same time. And that AH is classified according to P.340. You'll see the look of that in the sequence as it runs. The other standard implemented is ETSI TS126-132. It takes a little different approach. It does use real speech, but the result is classified as percent of time in several behavior categories. There's full duplex, there's clipping in 3 different time lengths, and there's echo in 3 different time lengths. Fortunately, there are some items in common with these 2 standards. First of all, they use the same test signal from P.501. They also use the same conditioning signals from P.501. And they use level versus time differences, which I'll explain in the next slide. The result of these common items is that one measurement can be used to implement both standards. Now, speech levels versus time, what does that look like? The speech waveform
The jacket hung on the back of the white
is indicated in gray. The level versus time is shown in yellow. You might say it's smoothed out. That's technically not totally true, but it is one way of looking at it. And the amount of smoothing depends on the time constant. Actually, in the standards, there are 2 different time constants in use, which the sequence implements. So, how do Doubletalk measurements work using level differences? It begins by playing speech from a mouth simulator into a device where the Doubletalk signal is played by itself and the level versus time is taken. Then the Doubletalk signal is played again, this time with the SingleTalk signal that's going in the opposite direction is present, and the level versus time again is measured. And there could be some differences between that and the first measurement, and that is shown in the difference. And so anything that is a positive difference indicates an echo that actually is audible, and the levels that are below indicate some kind of clipping or level loss. And if it's only brief, you may not notice it, but if it's long enough, it'll actually tell you that speech is being missed, perhaps even entire words. For this demonstration, we'll be testing a small USB speakerphone, and we'll use a standard mouth simulator. There's also a small microphone placed right at the acoustical opening of the speakerphone. That's used to synchronize the signals from the mouth with the sound as it comes out of the speakerphone. You'll see how that works when the sequence runs. The setup here is a fairly standard arrangement where the mouth is 50 centimeters from the device under test. When the sequence begins, you'll be given an opportunity to set some of the test parameters. The most important ones are the sending level from the mouth and the receiving level from the device under test. The defaults that will be shown here are pretty typical, and they will test the device under favorable conditions. But by changing those levels, you can test the device under less than favorable conditions where it may struggle a bit to provide full duplex operation. So when the sequence does start, you'll be given a prompt just to remind you about the setup, the positions that we showed you earlier. The sending level is pretty typical, but again, it can vary over a wide range. Also, the receiving level is typical, but it can also vary quite a bit. You'll also get a chance to put in a 100 Hz high-pass filter that's a good idea to eliminate noise that might otherwise be part of the measurement. And now we start.
The jacket hung on the back of the wide chair. The jacket hung on the back of the wide chair. The jacket hung on the back of the wide chair. The jacket hung on the back of the wide chair. The jacket hung on the back of the wide chair.
Grace.
Port is a strong wine with a smoky taste.
A pencil with black lead writes best. The shaky barn fell with a loud crash. The lamp shone with a steady green flame. They took the axe and saw to the forest.
The glow deepened in the eyes of the sweet girl. Pluck the bright rose without leaves. Clothes and lodging are free to new men. A cramp is no small danger on a swim.
5 5 5
5 5 5 5
5
The shaky barn fell with a loud crash.
Pluck the bright rose without leaves.
A pencil with black lead writes best.
The glow deepened in the eyes of the sweet girl.
Grace.
Port is a strong wine with a smoky taste.
A pencil with black lead writes best. The shaky barn fell with a loud crash. The lamp shone with a steady green flame. They took the axe and saw to the forest.
The glow deepened in the eyes of the sweet girl. Pluck the bright rose without leaves. Clothes and lodging are free to new men. A cramp is no small danger on a swim.
The last switch cannot be turned off.
5
It's easy to tell the depth of a well.
5
4 hours of steady
5
work faced us.
We
5
frown when events take a bad turn.
5
Rice is often served in round bowls.
5
The hogs were fed chopped
5
corn and garbage.
Jazz and
5
swing fans like fast music.
The juice of lemons makes
The
fine
shaky
punch.
barn fell with a loud crash.
To the dark blue
Pluck the bright rose without
He knew the
leaves.
skill of the great young
A pencil with
actress.
black lead writes best.
A chicken leg
The
is a
glow
rare
deepened
dish.
in the eyes
A
of the
large
sweet
size
girl.
in stockings is hard to sell.
Now that the signals have been played back and recorded, the sequence will do post-processing to get level versus time curves, and then do the statistical operations to get the attenuation range to implement the first standard. The yellow curve is level versus time for the period when both signals are going on at the same time. The gray areas are the areas defined as double talk. At this point, the sequence is calculating in a different way to implement the TS-126-132 standard. You can see the waveforms here, along with some areas that are being looked at in different ways. The yellow curve, again, is level versus time. The gray areas are defined as double talk. The red areas are defined as single talk. In the upper left box, you can see that the first part of the series, where there are words only, the word 5, is given 96.4% full duplex. The second part, which is full words, or sentences, is 95.6%. The next part is to calculate what goes on during the single talk portions. You may notice that There are some spikes of the yellow curve that extend above 0. Those are echoes that don't happen for very long, but they may be audible, and the sequence will evaluate that. There is also some attenuation in the single talk area, which may not be a bad thing. If you look in the second to the upper right box, you can see that there is not much activity in categories E, F, and G, but that is echo, which might be audible. That applies to the section where single words are spoken. That is the left-hand part of the curve. And now the same calculations are going to be applied to the right-hand part of the curve. And that shows, again, in levels E, F, and G, that there is some echo, but it might be enough to be audible. Double talk behavior is complicated, but the sequence offers numerical values that you can use to benchmark the behavior of a device as you're developing it. You can also dig a little bit deeper in the sequence and get some idea of why a device is doing what it's doing. The sequence is applicable to headsets, where double talk is sometimes an issue, but it's mostly applicable to speakerphones or any device with a speakerphone-like function, where two people are talking in real time back and forth and expect to be able to have a duplex conversation. You can use the sequence with hats or with a standard mouth simulator and a microphone. There's also supporting sequences to do calibration and also to set the volume controls on the device. Thank you for watching. Bye.